I'm actually gonna do let's start a sign-in sheet. So that'll be your in-class assignment grade for today. So get rewarded for being here. Keep your mouth shut. Don't tell your friends. You know, if they don't watch the video, they're hanging. Come to class. It's always a party the day after the test. So I wanted to show you where this stuff is applied. I really hate showing you the procedure first and then telling you the why, because you have to have a reason for why you do what you do. One of the hidden things that still is a challenge for medicine is pregnancy. And when I give pregnancy talks, students aren't usually that interested. But I'll give you a couple of reasons why you should be interested. One reason is you all came from a pregnancy. Hopefully. Hopefully everybody came from a pregnancy. The second thing is many of the things the diseases that we know of today appear like they might have started in utero. So if we can figure out some way to identify those complications as early as possible, maybe there's a way to turn it. Right now, there's not even a way to identify them as early as possible. So when you look at something like preeclampsia, preeclampsia is a very devastating disease. The mortality rates for mothers that have preeclampsia 10 years later are very high. So it appears to be a cause of death for the mother, and it causes problems for the baby, and it causes problems for the pregnancy. We can only detect that around 23 weeks or so, and the wheels are already in motion. So there's no way to intervene. Something's already gone forward. Gestational diabetes is another example of that. We see gestational diabetes in the 6 to 8 weeks. That's where they test for it. It's too late then. It's really late into the pregnancy then. So the problem with pregnancies itself is you can't look inside. With anything else, we can get an MRI and look inside your body. Even now with Alzheimer's, they used to have to autopsy the brain. We can actually go inside and look with fMRI, functional MRIs, and look at glucose metabolism in the brain. But for pregnancy, I know that in England, we work with someone in England that is doing MRIs during pregnancy, but he said one of the difficulties is getting mothers to sign up for that. Would you want to? It may cause a problem. Why would you want to risk your whole baby's life and get an MRI on a research study for as a volunteer? You wouldn't really want to do that. So that's the difficulty with MRI. X-rays, no, you don't want radiation. So we really don't have a way to peer inside the pregnancy itself. The data you're looking at here is from Forbes. I'm going to pass around Forbes book so you can see it. It's from our library, but you can see that it is indeed a medical book, but he looks at things from a data point of view. And this is old data, and in the long past, what they used to do is collect autopsy data from pregnancies all together and pilot. So what you're looking at is actually data that is from stillbirths. So they start at multiple cross-sections. They went out and looked at a population. So this is 15 weeks of gestation, and this is the fetal growth. And you see, as expected, the fetus is growing. The speed of the fetal growth is getting higher and higher. And he extended past birth when he plotted this data. What's interesting here is he's plotted the placenta. So I do a lot of work with a MD, MS in statistics. She's a placental pathologist. She works across the Staten Island, and she comes here to Montclair often, actually, if you would like to meet her. She's wonderful. But we've identified from the pregnancy itself, the placenta is so much easier to image with an ultrasound because it's kind of an elliptical looking thing. So the baby's like arms and legs, and it's moving around, so you have a hard time capturing that and getting a good feel about what the baby looks like. But from the placenta in an early ultrasound, we can see it pretty well. And so what we found is that the volume of the placenta, which is an ellipsoid, so I can actually calculate it, tells us something about what's going to happen later. So what you're looking at here is placental data. See this point up here? That's the maximum velocity of placental growth. And it looks like it occurs right around 25 weeks. In healthy pregnancies from the ultrasound, I found that it occurs about 7 weeks earlier. So why would there be a discrepancy in this data from the data that I'm looking at with ultrasounds? What do you think that would be? Say it again. These were stillbirths, and most likely they had some kind of delayed growth. So this peak point, I'm seeing it earlier. It's supposed to happen earlier. So this is a flag for some kind of delayed growth. And I actually show that. I'm going to show you that picture in a second. But here's the point I'm trying to make, why important to know these special functions, even though they're kind of fake looking. What I did is I dropped this data from this book. I just harvested it out and I put it in Excel. And so I put the gestational week here and just the X and Y data that you just saw. I just eyeballed it and put it into the graph. And you see that I can put a parabola. It's kind of like peaks and goes down. It doesn't give me a perfect fit. And I tried to raise the powers. You know, where you do trend line, you can go in there and tell it to do a polynomial. So it gives you the polynomial here. Then I have something like a very expensive version of Mathway, and I dumped it into there. So I want to find that peak. At the peak, the roller coaster is flat. That means the slope has to be 0 at that peak. So what I could do is take that polynomial, dump it into my version of Mathway, tell it to find the derivative, and tell it to solve for where it's 0. And it will tell me how many weeks exactly I should see that peak. And that's what I did. I put that polynomial, I copied and pasted it from Excel into here. I took the derivative. I don't care this times that, not that, it does it for me. So that's the second line that you're looking at. And the third line is solve it for 0. And it told me 28 weeks of gestation is when those silvers had that peak. So fake functions they may be, but I use them in this way. And in fact, we're preparing a paper for Nature right now. I'm going to show you that. It doesn't mean it's going to be accepted there. I'm preparing it for there. There is Nature placenta paper. The guy that does the MRIs came to visit us, and he was just staring at, I think, Elena, you might have seen him actually. He was in our, he was there. That was the team that was there, and that was him, yeah. So he was staring at this picture forever. So what you're looking at here is, I have a model now that will automatically find what we call that, it's called an inflection point. That peak point that you saw, this is a different display of that data. This is all ultrasound data that you're looking at. So these big blue blotches that you're looking at are healthy babies, all of them. And these pink are also healthy babies that came from St. Barnabas, all ultrasound data. These yellow are intrauterine growth restriction. So they were small babies, but too small. They actually were disease babies. And in fact, that UConn data that came from the University of Connecticut, those individuals actually they were doing drugs. So there was some kind of external factor involved in this. You can actually see that from their growth delay. The teal data that you're looking at comes from a study called PIN, Pregnancy, Infection, and Nutrition. The data is all ultrasound data, and again, or maybe it's birth data. It's birth data. So this is live births. This is not ultrasound. These are live births. They were born too early, and you see that the blue is the ones that have preeclampsia that were born in the PIN study, which is run, I think, in North Carolina. Over here, the blue is the UPenn at birth. Those are the healthy babies, and you can see that this curve here goes right through the healthy babies. So this is a normal growth curve of the placenta during gestation. This is where the max velocity is. This is a different way to look at max velocity. This is where the max velocity is predicted for the preeclampsia babies. Just like the silvers that you saw in the Forbes thing. It's about 7 weeks delay between these 2 points. So with this point alone, I can tell you within 7 weeks earlier than you can diagnose it now that there's a problem with the pregnancy. I can draw the predicted curve out, and if the inflection point is somewhere here, I can say there's a problem, there's a risk problem. And you can see that. You can see other things too. Yeah, the UConn, these triangles, all of them are falling below that normal curve. So you can see that, identify that. You never knew math could be used for this. Why is it one? You know what? So when people collect data, I like to work with certain sites often because they're very clean with their data. that looks to me like a mistake. But when it comes to me in an Excel spreadsheet, I don't know if I should include it or not. Because if it's a mistake, they have recorded it into their data files. When I work with pharmaceutical companies or I work with the Pennington Biomedical Research Center, those two places I get phenomenal data. Everything's clean, everything's double and triple checked by 3 different postdocs, so everything's careful. So I think that this was the placental pathologist by herself. She does, I think, 600 placental evaluations, tissue evaluations per year for Methodist. She's busy. So when she's piling things into her Excel spreadsheet, she's dying. I think this was collected by an OBGYN at UPenn, and he's pretty careful. These were small studies, but they were not large. The Yukon was large. She did all the histology on the placentas, and then she was putting all the data in probably by herself. So that's too much for one person and then making mistakes. I see it all the time. I have data from Colombia. Someone started out as a man, and in the final data, they were a woman. So something's wrong, with the data. Something is not. Then you start suspecting, like, is there something wrong all the way through? Can I trust this? And as a mathematician, I have to worry about it. Sometimes I discard the whole data set because I'm not sure enough. I need to be sure that what I'm getting is clean. Okay, let's get a circulation of the sign-up sheet. Is it going through? All right, perfect. I'm going to let you go early today. I gave you your homework, so you're done. There's a benefit coming the exam, day after the exam.